Hi everyone, welcome to this talk on the Survey.jl package. In a nutshell, we are implementing a package for complex survey analysis in Julia. This is based on the R package survey by Thomas Lumley. We aim to provide a more efficient computing framework that is required for the growing sizes of datasets. Surveys have become a standard tool for empirical research in social sciences. They've also become an important tool in market research in the industry. Complex surveys involve sophisticated techniques such as stratification, clustering, unequal probability sampling, or sometimes a combination of these. One of the surveys that we study at XKDR Forum is the Consumer Pyramids Household Survey. The survey is executed since 2014 by the Center for Monitoring Indian Economy. There are 236,000 households in India that are surveyed thrice a year. Income from various sources, expenditure on certain goods and services, assets, health indicators, etc. are measured. Our common tasks include producing summary statistics, for instance, the median income for each state for each month, and exploring relationships between variables such as the ill health rate and income, as one of the working papers of XKDR has explored. A number of software tools are available to analyze survey data. The survey package in R is a widely used open source option. Professor Thomas Lumley of the R core team has developed the package. Version 1.0 of Survey was released on 4th February 2003. This means it has experienced long years of stability and testing. Many resources are also available, including a book on how to analyze complex surveys in R and a research paper that highlights the technical details of the package. While the package excels in expressivity, it's not very performant. The package is completely written in R, while other packages use libraries written in C and C++. Advancements in the R ecosystem, such as using tables, haven't been incorporated in the package. This is probably because this will require changing the very foundation of the package. A Julia package can be an efficient alternative to the R package while matching it in terms of expressivity. Just a line by line translation of the code from R to Julia will result in a faster program. The performance can be further improved by exploiting the advancements made in Julia through various packages such as group by and combine in dataframes.jl. There have been attempts at implementing a package for survey analysis in Julia. I have mentioned two of these in the footnote. These haven't really materialized, however, it shows the interest on this topic in the community. As mentioned in the introduction, we are building a package in Julia for survey analysis based on the survey package in R. We will keep the API of the package as similar as possible to the R package, while the internal code will be completely different. It will be in a Julian way and exploit features such as group by and combine. We endeavor to achieve the following. We want to provide all the methods of the survey package in R, but in a more efficient way. We will provide a documentation that includes information on transitioning from R to Julia, and that will be illustrated through the examples that are provided in the survey package of R. The package will have numerical tests, including the cases that are there in the R package. And finally, we will have the cutting edge features of Julia, such as probabilistic programming. That's a lot for the future. Right now, we have implemented only a very small set of functions: mean, quantile, total, and generalized linear models. And a lot of stuff can actually be done just on the basis of these. As an organization, our primary objective is to do research. We will use this package to do research, and that ensures seriousness about the quality of the package and the correctness of the results obtained through it. If we obtain a result through it and that gets published in a paper, we will take full responsibility for that. At the same time, we feel that making it open source is necessary because it brings transparency. If there is any problem in our research, people will be able to find it out and point it to us. We will be happy with the criticism that people give us, and perhaps the help that they give us to improve the package, which will improve our research. Now I come to the second part of this talk. I will show you the R and Julia code side by side. I'll compare them in terms of expressivity, accuracy, and also perform benchmarks. So on the left, you see a Julia REPL, and on the right, you see an R session. So now we will load the libraries. In R, you would do library survey, and in Julia, you would say using survey, but with a capital S. We load the sample datasets that are provided with the package. Data API loads the API dataset. This includes 5 datasets, and we will use the API strat dataset. In Julia, it's the same syntax: data parentheses API. And again, you have all the API datasets, and we will use API strat dataset for this tutorial. To begin, we create something called a survey design. This contains information about the dataset and how or what kind of sampling was used to create it. For example, in this case, we say ID equal to tilde 1, meaning that it's a stratified sample. Given a column name instead of one, then it would be the clusters. Then it also contains information about which column contains the weights. It can also be probabilities. You can mention either of them, and you can also provide a vector for these instead of a column. You can see that the syntax in R and Julia is very similar. So instead of telling the column name using a tilde, we are telling it using a colon. So now we'll demonstrate the survey by function. This can be used to compute mean, quantiles, and total. In this example, we will compute the average of the API 00 score for each county. You see the similarity in the R and the Julia syntax. Again, instead of a tilde, we have a colon. We have not yet made these into keyword arguments. We are working on that. But you see that overall the syntax is quite similar. There are some differences in results. You can see it in the case of Orange County. The standard error answers are not exactly matching. This is because R performs a series of corrections on top of a regular standard error. We have implemented some of these corrections, but not all of them. And perhaps this could be one of the reasons for the speed, but I don't think that it's the entire story. However, standard errors are essential to survey analysis because using the techniques such as clustering and stratification, you aim to reduce this standard error. Now we'll come to the final function of our current package. We'll use the GLM function to find the relationship between API scores and number of meals. You can see the coefficients are nearly the same, both the intercept and the slope. We do store the other parameters that are there other than just the intercept, such as the AIC score. The AIC score, as you see, is quite different between R and Julia. This is not a GLM that we have built. We are just using the glm.jl package that exists in Julia. And we are exploring why this number is different. Now I'll come to the benchmarks to show the difference between performance in R and Julia. I'll use the micro benchmark library in R and the benchmark tools library in Julia. I will use the same functions that I've used earlier. So the same survey by call in both R and Julia. I believe the median time is about 350 times less in Julia. But now I will increase the complexity a bit. Instead of just grouping by the county name, I will group by two variables. This is county name and meals. It doesn't make much sense, but just to show the performance, I will do that. So Julia seems to be a lot faster, and it seems even faster when you're grouping by multiple variables. This is probably to do with the group by and combine feature. Finally, I'm going to show you the benchmark for the survey GLM feature. I will use the same call that I had used earlier in the example. So the SVY GLM feature for this example is about 30 times faster in Julia compared to R. I thank you for watching this talk. The survey package is not ready right now, so I'm not going to advise you to try it out. We acknowledge the support from MIT Julia Labs for this project. We thank Carlos Parada and Jose Santiago for their guidance on this project through Google Summer of Code. And finally, we thank Ajay Shah and Mausam Datta for their very valuable inputs.